Alrighty, guys, so we're ready to start our first unit for Geometry B, and this unit is going to be about polygons and quadrilaterals. And our first lesson is actually going to be talking about polygons. So, what we're going to look at is we're going to talk about what a polygon is, different ways to classify them, and then we're going to look at angle formulas for polygons. So, angles inside a polygon and angles outside a polygon, the exterior angles. We're going to look at all that today. And there is a lot of notes because I want you to know these definitions, but the actual math work you're doing is very, very simple. Okay, so don't be too freaked out. Okay, so let's get started. So we define a polygon as a closed (2D) or two-dimensional figure with straight sides. That's about as plain Jane as a definition I could give you. Okay, so it's got to be closed, meaning you can't have any gaps. It has to be two-dimensional, so it's flat, like a piece of paper. And then every side has to be straight. So, I mean, a good example is just this. I mean, there you go. That's a polygon. This one is not a polygon because it's not closed. And then this one is not a polygon because all the sides are not straight. Okay? All right. Now we're going to look at a convex and a concave polygon. So the best way I know how to describe convex is that all the sides point out. So what I mean by that, it means there's no indentions in the polygon. Or cave-ins. Like it doesn't fold back in on itself. So this is a convex polygon right here. See, every side points out. You know what I'm saying? Nothing comes in on itself. Okay, a concave polygon has an indentation. Or a cave-in. So I mean, you could start to draw one, and then oops, it comes in. That's a concave polygon. It kind of caves in on itself. If you think of it that way. I mean, you could have multiple cave-ins. You could do it like this. Let me make it connect. You could have multiple cave-ins. Okay, let's speed that up a little bit. Okay, so that's convex and concave, and that's going to be one of the classifications you have to do is tell me if it's convex or concave. And the next classification we have to talk about is if a polygon is regular or not. And so before we talk about regular, we got to talk about what equilateral and equiangular are. And this should be familiar. I hope it's familiar, but if not, it's really easy to figure out. An equilateral polygon means that all the sides, notice its sides, are congruent. So you could draw, notice it says nothing about the angles, it's just the sides. So I'm going to try and draw what we'll later call a rhombus. all the sides are the same. And we know that because I could put these little tick marks there. Okay? An equiangular polygon means that all the angles are congruent. Okay, so it's nothing about sides now, it's about angles. So the easiest one I can think of is a rectangle for a four-sided shape. Because we know that in a rectangle, all the angles are 90 degrees. And then finally you have regular. So this is when the polygon is equilateral and equiangular. Okay? So a regular polygon, it has to have all the sides the same length and all the angles are the same measure. So if we're thinking of in four-sided shape world, the regular one is the square. Because every side length on a square is the same, and then every angle is 90. Okay, so those are the definitions we need first. And we're going to classify by convex, concave, or regular, not regular. And that's what we're going to look at. Okay, so determine if it's convex or concave. And I tell myself, does it cave in on itself? Do you see any indentions? I see no indentions, so this would be a convex polygon. On this one, I see two indentions, so this is concave. That's literally all you do for those kinds of problems. Easy peasy. Now, determine if it's regular. So remember, regular has two things we have to check for. We have to check if all the angles are the same and all the sides are the same. We have to check both of those conditions. And the way I've set these problems up is it's kind of just by sight. So kind of eyeball it. So if I'm looking, it looks to me like all the sides are the same, so I could go around and put a little tick mark on every side. And then if you could rotate the paper, you could see that all these angles are the same measure. And if you had a protractor, I mean, you could actually measure them. So this one is regular. Now looking at the second one, I automatically know it's not regular because every side length is not the same length. So this is not regular. And that's it. Okay, so that's the first level of classification is convex, concave, regular, not regular. The second way is that you actually give me the name of the polygon, which is what we're going to look at next. So, and this should be familiar, but I'm going to run through the names anyway. So we name polygons or classify them by the number of the sides. And so, of course, 3 is a triangle. 4 we call a quadrilateral. 5 is a pentagon, because penta means 5. 6 is a hexagon. 7 is heptagon. 8, octagon. That would be your stop signs. 9 is a nonagon. 10 is decagon. We skip 11 because usually we don't use 11, and 11 has a weird name. So we just skip it. 12 gets its own name. 12 is a dodecagon. And then for anything 11 and 13 and up, we normally just call n-gon. So n would be the number of sides. So 14 gon, 20 gon, 25 gon, whatever. Okay, all these names you need to know on the back, like the back of your hand. You've got to know what these names are. Because what we're going to look at with the angle problems is I'll ask you to find some sort of angle formula for, let's say, hexagon. So if I just give you the name, you have to know the number of sides. Okay. And then just to make sure we know how to classify by name, all I'm going to do, count the sides. 1, 2, 3, 4, 5, 6. 6 sides, that's a hexagon. There you go. Start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be a nonagon. Okay. Okay. On to the big thing. This is like the important part of this whole lesson. So there are formulas and theorems about angles in a polygon. You have interior angles, which are angles inside the polygon. And then you have exterior angles, which are angles that are outside the polygon. And so the two things we look at the sum, meaning when you add them all up, and then we look at the measure of one singular angle. And I've kind of bolded the key words for you here so that when you read a problem, you know which formula or angle theorem to apply. Okay? So the sum of the measures of the interior. So the keywords here are sum and interior. So the sum, that is a terrible S, excuse me. This is interior sum, so let's do this. Interior sum equals n minus 2 times 180. And n is always going to stand for the number of sides. Okay? Now, if we had time, I would actually have you investigate and find out where that formula comes from. But for time's sake, we're not going to. I'm just going to tell you, hey, it's this. So all you need to do is, when you know the number of sides, plug it in for n, type in the calculator. And they're going to be bigger numbers, okay? So don't be scared when they're like 2,000 degrees, okay? You're adding up every angle inside a polygon. Okay? The measure of one interior angle of a regular. So now this time, if I ask you for one single angle, it has to be from a regular polygon. Otherwise, the formula doesn't work. This formula works no matter if it's regular or not. But this one has to be regular. Now, what I want you to do is kind of go ahead and divide this in two. Because there's two ways to do this one. And I'm going to show you both. And you get to pick whichever one you want to do. So for one angle, or the first way to do it, you still start by finding the sum, but then you divide it by the number of sides. And here's why this works. So this is a regular polygon. Remember, regular means that it's equilateral and equiangular. All the sides and all the angles are the same. So if you add up every single angle, which is what this is doing, and then you divide by however many angles there are, it's going to give you one angle because every angle is going to be the same. Okay? So this is option 1. Option 2, I'm going to come back and talk about after I talk about this one. Okay. The sum of the measures of the exterior angles. So, in case we don't remember, let me draw this up here. Let's say you have a some four-sided shape, and then you just extend one side. This angle right here with one dot is going to be an interior angle. This one with two dots is an exterior angle because it is outside the figure. So when I say exterior angle, this is what I'm talking about. All right. So this theorem says when you add up every exterior angle, let me just extend them all just so you can see. So all the ones with two dots, when you add them all up, and this formula or theorem, no matter what the polygon is, this is always 360 degrees. Always. No matter the shape, if it's a quadrilateral, if it's an hexagon, octagon, decagon, 25gon, does not matter. The sum is always 360. Now to find this one, this is the measure of one exterior in a regular. So again, it has to be regular. We take the sum, 360, and divide it by the number of sides. Okay? Now, let's go back and talk about option 2 right here. You can actually use this formula as the first step to get this one, and here's why. Look at this relationship right here between this interior angle and this exterior angle. If you add those two up, you actually create a straight line, a straight angle. It adds up to 180 degrees. So what some kids like to do is they actually like to start and find this one first. So the first step here would have to be 360 divided by n, and that will get you an exterior angle. And then because exterior plus interior adds up to 180, we can then do 180 minus the exterior angle. Okay? And on the examples in the notes, I'm going to show you both of these for the examples I have, and you get to pick whichever way you want to do, because I don't really care. Okay, so these are the formulas you need to know. I could ask you this like a one-time question, but these are the ones we're really going to focus on because they change depending on the polygon. All right. Find the sum of the measures of the interior. So I'm looking at my sum interior. That's my keywords. So I'm going to go back and use this formula because that's for sum of interiors. My sides are 15, so I'm going to do 15 minus 2 times 180. And just like that, type it in this calculator. 15 minus 2 times 180, 2,340. So 2,340 degrees. I want to say degrees because we're talking about angles here. Okay? So find the sum of the measures of the interior angles of a nonagon. How many sides is that? That's 9. So 9 minus 2 times 180. And if you type that in the calculator, you will get 1,260 degrees. Okay? You could see this problem on your homework as if I give you just the picture, the actual shape, like I'll give you a hexagon, and so you just have to count the sides. But it's the same work. Okay? Now, for these ones, I'm going to split this box in half because I want to show you both methods. All right? So the first method is we're going to do n minus 2 times 180 over n. So n stands for number of sides. Well, they told me a decagon, so that's going to be 10 sides. So I'm going to do 10 minus 2, 180 over 10. What will that get me? Now, to type this, that's essentially a big fraction. So I want you to use alpha y equals and type that in all at once. 10 minus 2, 180, come down and put 10, and you get 144. Okay, if this comes out as a fraction, just convert it to a decimal, because I want the decimal form of it. Now, remember, you could also start with the exterior angle first. So what you could do is do 360 and divide it by 10, and that will get you 36. That is how big the exterior angle is. And remember, exterior plus interior equals 180. So if we do 180 minus the exterior, that will get us the interior. And that's also 144 degrees. Either way, I don't care. All right, again, up top, I'm going to do 16 minus 2 times 180 over 16. And you type all that into a big calculator, you get 157.5 degrees. So let me show you on that one what I was talking about earlier. So 16 minus 2, oops, forgot my parentheses. 16 minus 2, 180, 16. Now see, it gave it to me as a fraction. So what I'm going to do is go to my math menu. See that second one that says decimal? So I'm going to select enter on decimal, and then it gives me my decimal, which is what I want. Or I could do 360 divided by 16, and that's going to get you 22.5. And then 180 minus 22.5 equals 157.5. Okay? Find the measure of each exterior of a regular hexagon. Hexagon means 6 sides. So 360 divided by 6, that's going to be 60 degrees. Same thing, 360 divide 24, that's 15 degrees. There you have it. That's all there is to it. So let's make sure we have this video, we watch it all the way through. We have our notes copied for references, and you complete your assignment. I think there's 24 homework problems, so it shouldn't take you too long. But if you need help, just let me know.